Okay, so get your Cornell notes ready. Today is October 8th, 2014. The topic is proportionality, and we're going to cover fractions, decimals, and percents. The essential question that you should be able to answer at the end of these notes are how are percents, fractions, and decimals related, and how can you use those relationships to solve problems. Understanding percents is the first section. We're going to try to understand what percents are looking at models. So here we have 17%. Well, a percent is a special kind of ratio, which is compared to 100. So the symbol that you see is what we use to show percent. So 17% is equivalent to 17 to 100, or 17 to 100, or 17 to 100. And these are the three different ways to write those ratios. Right below there is a model of a 100 grid, and you count the blue squares that are shaded. You have 17 blue squares shaded in. So this represents 17% of the 100 grid is shaded. You have your recording sheet, and I want you to use set 1 and follow along with me on this part. So we're going to model 1/4. This one is the easiest to show 1/4 because you have 4 parts and the numerator tells me 1 is shaded in. So there we have our 1/4. Here we have 40 pieces. So we would take 4 times what will give me 40, which is 10, and 1 times 10 is 10. So that means 10 pieces would be shaded in. We have 20 pieces here. So again, 4 times what gives me 20, which is 5. So 1 times 5 is 5. So that means we're going to shade in 5 pieces. And here's that 100 grid again. How do we get from 4 to 100? Well, 4 times 25 is 100, so 1 times 25 is 25. So we're going to shade in 25 pieces. All of these are equivalent ratios to 1/4. Here we have a guided practice problem. The free throw ratios for 3 basketball players are shown. Player 1, 17 to 25. Player 2, 33 to 50. Player 3, 15 to 20. Which player has the greatest free throw ratio? But that's pretty difficult to see just looking at their free throw ratios. So we're going to use models to help us figure out which player has the greatest free throw ratio. And when we create those models, then we'll be able to put our percents in order from least to greatest. So we want to rewrite each ratio as a number compared to 100. Then shade in the grid to represent the free throw ratio. So player 1 was 17 to 25. How do we get from 25 to 100? We multiply by 4. So that means we're going to multiply 17 by 4 and get 68. So we would shade in 68 pieces of our 100 grid, and 68% of our 100 grid is shaded in. Player 2 is 33 to 50. How do we get from 50 to 100? We multiply by 2. So 33 times 2 is 66. We shade in 66 pieces of our grid, and we have 66% shaded. Then we have player 3, 15 to 20. And we multiply 20 by 5 to get to 100, so 15 times 5 is 75. Again, shade in 75 pieces of our grid, and we have 75%. So now that we have the percentage of each player's free throws, now we can go and answer our question. Which player had the greatest free throw ratio? And that would be the player with 75%, which was player 3. And then we want to put our percents in order from least to greatest. So the player with the lowest percentage was player 2. So player 2 would go first, and then player 1. And the greatest would be player 3. So 66%, 68%, 75%. Now I want you to take some time, go ahead and pause the video. There is more, so you need to come back. But first, go ahead and complete set 2 on your recording sheet to model the fraction 2/5. So in all of the models in set 2 need to represent 2/5 of it shaded. The next section we're going to talk about is benchmarks and how we can use benchmarks to help us find the percentage or estimate fractions. So we have two number lines. The first one is from 0 to 1, and you have your fractions, and those are our benchmark fractions: 1/10, 1/4, 1/3, 1/2, 2/3, 3/4, and 1/2. Right below that we have 0 to 100%, and then we have the percentage benchmarks right below their fraction benchmark. Take some time to study these benchmarks so that you have them in your head. Let's use the benchmarks to help us solve for the equivalent percent of 3/10. So 3/10, we need to find a benchmark that 3/10 is closest to. Since it has a denominator of 10, I would think it's closest to 1/10. So we're going to use that benchmark. And you have to think about pulling apart 3/10 so that we represent the benchmark 1/10. So we have 1/10 plus 1/10 plus 1/10. Well, what is 1/10 as a percent? 1/10 as a percent would be 10%. So we would multiply the 10% by the 3, and we would get 30%. So 3/10 as a percent is 30%. Let's look at guided practice problem 2. We have 76% of the students at a middle school bring their own lunch. About what fraction of the students bring their own lunch? Well, 76% is very close to the benchmark 75%. So we're going to use 75% to give us an idea of about how many students bring their own lunch. And 75% written as a fraction is 3/4. So we would answer this problem: about 3/4 of the students bring their own lunch. The next section is writing fractions as decimals and percents. If the denominator of a fraction is a factor or multiple of 100, then you can create an equivalent ratio and easily convert the decimal and percents. If the denominator is not a multiple or factor of 100, then you have to divide the numerator by the denominator to create the decimal or percent. Let's look at example A. 96 out of 200 animals treated by a veterinarian are horses. Write 96 to 200 as a decimal and as a percent. So since 200 is a multiple of 100, we are able to get the denominator to equal 100. And in this case, in order to get 200 to equal 100, we have to divide by 2. So what we do to the denominator, we have to do to the numerator. So 96 divided by 2 is 48. Now that we have a ratio that has 100 in the denominator, we can create our decimal quite easily. 48 hundredths written as a decimal is exactly how it sounds when you read the fraction, 48 hundredths. And then you can easily go from that to your percent, which is also 48%. Example B. We have 1/8 of the animals treated by the veterinarian are dogs. Write 1/8 as a decimal and as a percent. Since we cannot easily go from 8 to 100, there's nothing that we can multiply or divide to get to 100 from 8. That means we have to use long division, and we have to divide our numerator by our denominator. So the decimal for 1/8, so 1/8 as a decimal is 125 thousandths. To write the decimal as a percent, again, you would write it just like it sounds. 125 thousandths equals 125 thousandths as a fraction. And remember, our goal is to get a denominator of 100. So how do we get a denominator of 100 if we have a denominator of 1,000? You divide by 10. And then you divide 100 25 by 10, and you get 12 and 5/10. So 1/8 written as a percent is 12 and 5/10%. Example C, here's the process of going through actually converting a fraction to a decimal. It's very similar to when we're doing an improper fraction to a mixed number, but instead of turning the remainder into a fraction, you're going to turn it into a decimal. So here we have 5/6, and of course, since 5/6 is less than 1 whole, we are not going to have a whole number when we divide. It's going to be a decimal, less than 1. So 6 does not go into 5, so we have 0. I'll go ahead and multiply 6 times 0 is 0 and subtract, which gives me 5. And here's where we're going to add our decimal. Add your decimal behind the 5 and then take it straight up into our quotient. And then right behind the decimal, we're going to add our 0, our placement 0. And then we're going to bring it straight down. So now we have the number 50. So what times 6 gives me 50? 8. Oh, I didn't mean to do that. 8. And then we have 48, and we subtract. 50 minus 48 is 2. And since we still have a remainder there, we need to add another 0 and bring it straight down. So now we have 20. What times 6 gives me 20? 3. Which gives me 18. 20 minus 18 is 2. Again, we have a remainder, so we need to add another 0. And we have 20. What times 6 gives me 20, or close to it? 3. So what's going to end up happening? We're going to keep going on and getting 20 and having to do 3. So 3 is going to continue to repeat. In 6th grade, we go ahead and stop 3 decimal places behind. So we only go up to the thousandths place. So you don't have to go any further than that 3rd decimal place. So we're going to stop right there, and we're going to have our answer. 5/6 written as a decimal is 833 thousandths. Well, what is this little line right here above the 3? Well, this little line above the 3, it is a symbol that tells us that that 3 is going to be repeated infinity. So instead of us having to write it down an infinity amount of times, which is impossible, we just use the symbol with the line over the 3 to show that this number repeats. So here are some practice problems that I would like for you to complete in your notes. And once you have those completed, then we will be ready for class and for our stations. Please make sure you go back and re-listen to any part that you need to make sure that you are clear on. This was a long video because it had a lot of information. And that's why it's important to re-listen to the video. I cannot stress this enough. Please go back and listen to any parts that you need clarification until you have listened to it so many times, and if you still don't understand, then you need to seek help. But until then, make sure you re-listen, write your notes, and have those questions in the corner in our Cornell Notes section here if you have any questions still that I can help you with.